Dear students, Assalamu alaikum and welcome to e-learning Al Noor International School, grade 9 chemistry course. I'm your chemistry teacher Faraz Anjum. Today we will discuss chapter 6, the periodic table, lesson 3, periodic trends. In this lesson we will discuss textbook pages 178 till 182. So please open your textbook and page number 178 first. The resources you need in this lesson: textbook, notebook, periodic table, pen and pencil. Periodic table you can find inside the book, but it is much better to have handy periodic table like a A4 size, or you can read easily. Our main objective is today describe trends for first ionization energy, ionic size and electronegativity. Remember, these two objectives we already finished. Okay students, trend in ionization energy. Before I start the trend, first we have to know what is ionization energy. So the simplest definition of ionization energy is the energy required to remove an electron from an atom is called ionization energy. So here is the three different atoms. First atom lithium, second sodium, third one potassium. Okay, now in these atoms, when you focus, you notice that all they have one electron in the outermost shell. Outermost shell, valence shell. Okay, outermost shell called valence shell. Remember this term. So valence shell, how many electron? One. Valence shell, how many electron? Only one. Valence shell, how many electron? One. So it means it belongs to group 1. It belongs to group 1. So all these elements belong to group 1. Group, remember, vertical column. Okay, from here you can see in the periodic table, vertical column. Okay, group 1A. So first hydrogen in your periodic table. So leave the hydrogen because it's a non-metal. Start with the lithium. So start with the lithium first. After that you can see in the periodic table sodium, then potassium. Okay, so from top to bottom we are going. So what is it? The energy required to remove the electron, this electron. Okay, normally it's from the outermost shell, first electron. So remove the outermost electron, okay, from the valence shell is called ionization energy. So energy required to remove this electron is called ionization energy. Now the proper definition of the ionization energy is supposed to be like this: the minimum energy required to remove an electron or valence electron from the outermost shell in gaseous atom is called ionization energy. One more time I am repeating: the minimum energy required to remove valence electron from the outermost shell in gaseous atom, okay, or from the gaseous atom. Okay student, what is gaseous? Gaseous atom means single atom, means one atom, not in diatomic or compound form. Single atom, free atom you can say, or the good one is free atom. Yes. All right, now when you understood the ionization energy, let's start with the first ionization energy tends to decrease from top to bottom, means from top to bottom ionization energy decreasing in a group, and increases from left to right, means from left to right when you go it increases. From group top to bottom decrease, left to right increase. Okay, you notice here first ionization energy. What does it mean? This means first electron, the energy required to remove first electron. This is first electron. To remove this is called first ionization energy. Okay, second electron remove, second ionization energy. The energy required for this is called third. Okay, so let's 4 5 6 no and going on. Okay, so here we go. First ionization energy. The energy required to remove the first electron from an atom is called first ionization energy. The first ionization energy tends to decrease from top to bottom within a group and increase from left to right across the period. We discussed already there. Okay, so ionization energy can help you predict what ion an element will form. Means it could be positive or it could be negative. Because of this ionization energy, we can do it. It is relatively easy to remove one electron from group 1 metal atom, but it is difficult to remove second electron. This difference indicates the group 1 metal tends to form ion within one positive charge. Means all the group 1 have one positive because they can easily remove the outermost electron. Okay, friends. Now, in the periodic table from left to right, as we know that ionization energy increases and top to bottom in the group is decreases. So let's start with the period. In the period, you can start from here lithium till fluorine. Okay, leave the noble gases. So start with the lithium. Lithium is how many electron? 3, you can see. And how many electron? Proton are the same in the neutral atom. Remember last time we discussed this. So 3 proton, 3 electron going to attract in the lithium, and then beryllium 4 to 4, 5 to 5, carbon 5 to 6 to 6, then 7 to 7, then oxygen 8 proton and 8 electron present, and fluorine 9 proton and 9 electron present. So who has the more attraction, lithium or fluorine? Because in the same period, okay? Because on the same period. Obviously, fluorine is more attraction because fluorine has 9 proton and it has 9 electron. So more attraction. This nuclei attract more forcefully the electron than the lithium because it has more charge. Simple. Okay. Now, one thing you notice maybe from here to here, the shielding effect remain constant. What is shielding effect? Last video we discussed this, that the shielding effect means the attraction between the nucleus and the outermost shell. If any shell going to block, this blockage called shielding effect. Okay, so this is the nucleus and this is the outermost shell. So what is the shielding effect for this? One shell only. Here one shell, here one shell, one shell, one shell, one shell, one shell, one shell. So means all from lithium to fluorine, shielding effect not going to change, means remain same. So shielding effect same means the distance is same. But why they get the more attraction? Because number of proton and electron increases, charge increases. When the charge is increase more, so which one easy one, lithium or fluorine? From where we can remove the electron easily, from lithium or from fluorine? This is my question. Think. Good. I hope that you answer. Lithium. Why? Because lithium has less attraction. Okay, so is the less attraction on this electron, we can remove very easily. Okay, so remember ionization energy, what is it? The energy required to remove the electron. So we need less energy to remove this electron. But when you go here, little bit more than the lithium, here more than the beryllium, then here more than the boron, then nitrogen is more than the carbon, then same oxygen more than the nitrogen, then fluorine is the highest one or need much more energy than the oxygen as well. So from here to here, when you go from left to right in the period was, ionization energy going to increase because charge is increased. When charge is increasing, the attraction between the nucleus and the outermost shell, outermost electron going to be more, so we cannot remove this electron very easily. We need much more energy to remove this. Okay, so I hope you understood this. Okay, our next topic is trends in ionic size. Ionic size tends to increase from top to bottom within the group. Generally, the size of cation and anion decrease from left to right across the period. Before I explain this, we should know that what is meant by the ionic size. Remember, positive and negative ion form when the electrons are transferred between the atom, means especially the metal and non-metal, the ionic bonding. Okay, which compound? Ionic compound, ionic bonding you can say. In the ionic compound, or you can say in metal or non-metal. Okay, so when metal and non-metal combine together and make the bond or make a compound, what will happen? Metal transfer the electron to the non-metal. So who's losing the electron? Metal. Who's gaining the electron? Non-metal. Remember this. Okay, so losing the electron means become positive ion, and gaining the electron means become negative ion. We discussed last week this. So cation always is smaller than the atom from which they form. This one we discussed already last week. Anion are always larger than the atom from which they form. Okay, group trend in ionic size. So let's start with the metal first. For metal element, the ion is much smaller than the atom. Now you can see this. This is the lithium atom, this is ion. So atom is bigger or larger, and very small the ion. Same, sodium is larger than sodium ion, and potassium is larger than its ion. But you notice as well one more thing, not the atoms, okay, as well as in the ion, lithium ion is smaller than the sodium ion and then the potassium ion. So you notice this, that ion size, the size of the ion become larger, increasing. So in the group wise, ionic size from top to bottom increases. Okay, doesn't matter is positive or negative ion. Before go there, one thing I have to tell you here, that why it happened like this, because of the shielding effect. Number of shell going to be increased. Okay, so number of shell going to be increased means more volume. Okay, the periodic trend of the ionic size. From left to right across the period, two trends are visible. The gradual decrease in the size of positive ion, cation, followed by the gradual decrease in the size of negative ion. Okay, now we're going to discuss with the period wise before we finish the group wise. Okay, now period. In the period, you can see from here to here, lithium to fluorine. Okay, so in the lithium, we already know that lithium has 3 proton and 3 electron, and here how many? Fluorine, yes, 9 electron and 9 proton. So let's start. So lithium, which ion going to be formed? Positive or negative? Positive, because it loses the 1 electron. Then go ahead, beryllium, yes, positive, good. Then boron, positive. Carbon, normally positive, it could be negative, but from here anion, negative. Nitrogen negative, oxygen negative, fluorine negative. So these from here to here cation, from here to here anion. But both, doesn't matter is it cation or anion, the size of the ion, cation or anion, both is going to decrease. It's going to decrease. Doesn't matter is cation or doesn't matter is anion, it's going to be decreased. Why? Because of the attraction. Same thing, one logic I told you earlier last week the video, that remember one thing, from left to right, number of proton or electron increases, charge increase. So when the charge increases, attraction going to be more. Okay, remember. And from top to bottom, number of shell going to increase, means shielding effect increase, volume become more and attraction become less. That's the reason only. Okay, so from left to right when you go, because of the number of proton and electron increase, charge going to increase and attraction is going to be increase. When the attraction going to be increase, so ionic size going to be decrease. Okay, so from left to right, ionic size going to be decreased. So simple thing that like atomic radius or atomic size, we discussed this. I hope you understood this. Now the most important one, the trends in the electronegativity. Before we start everything, first you have to know what is electronegativity. So electronegativity is the ability of an atom of an element to attract the electron when the atom is in compound, or the proper one I'm going to explain here. Look here, one atom X, other atom Y, and this one is nucleus, this one is nucleus, but dot represent electron of this atom and cross represent the electron from this atom. In when it's going to be make the molecule compound, in a molecular compound, especially covalent bond. Okay, bonding, don't worry about the bonding, we will discuss later. But remember, like in a molecule, in a covalent molecule, you can say they shared the electron to make the bond. This is bond. Okay, so to make the bond they share this electron pair. So now after sharing this electron pair, these are two different atoms. Remember, when they both are different atom, the power is definitely different. Think like this. Suppose this is H and this one is Cl. Hydrogen, H and Cl. Hydrogen has how many electron? One only. How many proton? One. And chlorine has how many electron? 17. How many proton? 17. So who has more power? Definitely chlorine. Okay, so what will happen? This going to be the chlorine going to attract both shared paired electron toward itself. Okay, so the ability of an atom to attract the shared pair of electron in a compound toward itself, this ability called electronegativity. I'm going to give you easy example for this. Think like this, that your brothers, okay, you have, okay, your age suppose 15 year and your brother age 5 year. Okay, and this is shear pair of electron considered as a chocolate box your parent gave. Okay, when they give you this chocolate box, 5-year-old boy attack on it, 15-year-old boy attack on it, and they are now pulling each other. After your parent disappear, they are pulling each other, that no, I will open, no, I will open, no, I will open, no, I will open. So but in this fight, who will win? Yes, obviously age of 15, because he has more power. So the shared pair of electron attract toward itself because of the power. Okay, so the electronegativity of 15-year boy is more than the 5-year-old boy. Understand? Same thing happened here as well. Okay, so what is electronegativity? The ability of an atom to attract the pair of electron toward itself is called electronegativity. So what is the trend in? In general, electronegative value decreases from top to bottom in the group, decreases, remember. Okay, and from representative element, the value of 10 increases from left to right. So left to right, when you go in the period, across the period wise, it's going to be increased. So it means from left to right, electronegativity increases, and from top to bottom, electronegativity decreases. One word you heard this one here, representative element. So remember, representative element means the main elements. okay, which are S block and P block element. Which one? S block and P block, or group A. You know, there are two division, means A and B, like 1A, 2A, 3A, 4A, 5A, group 7A, like in the periodic table. Okay, so these called representative element. Okay, students, now this table shows the electronegativity values. The electronegativity, remember one more time, that the ability of an atom to attract the shared pair of electron toward itself. So as we discussed that from left to right when you go, the number of proton and electron increases. So lithium has 3, fluorine has 9 number of proton. Okay, so 3 proton, 9 proton, 3 electron, 9 electron. So attraction, who has more attraction? Definitely fluorine. So when the attraction is more, means this fluorine has more power to attract the other as well, like a 15-year-old boy and 5-year-old boy, as I gave the example. So from left to right when you go, the electronegativity going to increase because attraction or number of proton going to increase, and it has the more power. From top to bottom in the period, number of shell going to be more, like lithium has 2 shell only, 3, so potassium has 4 shell, rubidium 5, then 6, like this. Okay, from left to, from top to bottom, what going to happen? Number of shell going to increase. When the number of shell increasing, it means shielding effect become more increasing. When the shielding effect more, means the attraction between nucleus and electron will be less. So when the attraction is less or power is going to be low, how we going to be attract the other electron? That's why it's called from top to bottom. When you go in the period wise, electronegative value going to be decreased. So you can see that 1, 0 0.9, 0 0.8, okay, it's going to be decreased like this, and from here it's going to be increased. See, 1.0, 1.5, 2.0, like this. And the who has a more maximum on all over the periodic table? Fluorine, 4. Okay, and who has the least one? Cesium, 0.7. Okay, next is overall everything we're going to summarize here: atomic size, atomic number, ionization, everything. So remember here, atomic size from left to right decreases, ionization energy increases, electronegativity increases, nuclear charge increases, shielding effect remain constant. So these two is a reason of them, that atomic size, ionization energy, electronegativity here increasing, and this one is decreasing because of nuclear charge increase. Nuclear charge means number of proton going to be increased, and shielding effect remain constant. Shielding effect means number of shell remain same. That's why this one. Now go for top to bottom. Atomic size increases, ionic size increases, ionization energy decreases, electronegativity decreases, nuclear charge increases, shielding effect increases. Because of the shielding effect increases, that's why everything going to be happen here. Okay, so size of cation decreases, size of anion going to be decreases on this side. So this is all summarized whole lesson. I hope you understood everything. Thank you so much, student. Hope you enjoy everything, and then do your assignment on the Pearson as well as the worksheet, and please complete your section assessment and workbook yourself at home. Okay, and write the comment when you finish the section assessment and workbook as well, and worksheet on the Schoology. Okay, thank you so much.